Hello students, in this part we will discuss on soap and detergent, how soaps and detergents are produced and what are the uses of soap and detergent and how the soap cleaning the clothes. Soap and detergent. Soap and detergent both are carbon compounds. Both are carbon compounds, a long chain. First of all, how we can prepare soap? We can prepare soap. That process is called saponification. Saponification. What do you mean by saponification? The process in which we prepare the soap, that is called saponification. Soaps are produced when vegetable oil or animal fat is heated in presence of sodium hydroxide or potassium hydroxide. Animal fat, as well as we can say that vegetable oil is heated in presence of sodium hydroxide or potassium hydroxide. Then we produce soap. It is heated, and one byproduct that is called glycerine. What is the chemical formula of vegetable oil? We can take the two types of vegetable oil, palmitic or stearic. In stearic vegetable oil formula is C17H35 COO CH2 CH2. This is bonded with this one. This is the chemical formula of stearic oil. We can take this type of oil also, or palmitic oil. In palmitic oil, the chemical formula is C15 H31 COO CH2 CH or CH2. These are bonded with each other. This is the palmitic oil chemical formula and this is the stearic oil chemical formula. How we can prepare soap? We can prepare soap when sodium hydroxide or potassium hydroxide is heated in presence of this type of oil. We can produce soap, and a byproduct glycerine is also produced. So write down the chemical formula of formation of soap. Firstly, we'll take the stearic oil. C17H35 CO with the CH2 CH and CH2. This is the chemical formula of stearic oil. When this stearic oil heated in presence of sodium hydroxide NaOH, we can obtain soap. The chemical formula of soap is C17H35 COONA. It means C17H35 COO, and this Na comes here. This is the chemical formula of soap. And next byproduct is produced. That byproduct is CH2OH, CH2CH, CH2. This CH2 CH and CH2 bonded with each other, and it bound with the OH hydroxide with all. There are 3 hydroxide ions, so we can take here 3 to make the chemical reaction balanced. There are 3, this one also 3. This is the chemical formula of soap, and this is the chemical formula of glycerine. We can write down the chemical formula while we prepare food or soap. Take the vegetable oil. The vegetable oil may be steatic or palmitic. When steatic or palmitic oil heated in presence of sodium or potassium hydroxide, we can take both type of, because we know that soap are the long chain of sodium or potassium salt. So we can take it sodium as well as potassium. It produces sodium ethonate, or when we take potassium, that is the potassium ethonate, and one byproduct is produced, that is called glycerine. This is the chemical equation of formation of soap. We can write down this one also. Simply, how we can produce soap, we can take the process of saponification. What do you understand by saponification? When ester is heated, in presence of NaOH or KOH, we can obtain ethanol, CH3, CH2OH. This is the chemical formula of ethanol. And soap, CH3 COONA. If sodium hydroxide taken, if potassium hydroxide is taken, then it will produce CH3COOK. Sodium ethonate or potassium ethonate. We can write down this chemical equation also and this one. But one main important question is, name the byproduct which is produced while we prepare soap. That byproduct is known as glycerine. This is the formation of soap. In simply way, we can prepare soap at home. How we can prepare soap at home? Preparation of soap. Take 30 ml of vegetable oil and add 60 ml of 20% sodium hydroxide as well as potassium hydroxide, whether it is sodium hydroxide or potassium hydroxide solution, and start to heat the mixture for 5 to 10 minutes. When it changes into a paste, as this mixture start to convert into a paste, add 5 gram of NaCl, sodium chloride or common salt. Why common salt is mixed with this type of paste? Because common salt helps the paste not stick with the utensils. Because common salt, when it is poured on this mixture, it vaporized, and the water molecules may be produced. The water which is produced, that comes down the bottom of the utensils, and the paste doesn't stick with the utensils. And slowly cool down this mixture. The upper surface the upper surface which is white, that is soap, and lower side the dark is called glycerine. So it is the preparation method of soap. What is the structure of soap? A soap has two ends. Firstly, a soap is a long chain of sodium or potassium ions. Soap is a long chain of sodium or potassium ions. A soap has a long chain of carbon compound which has a head and a tail. It is a head and this one is a tail. A long carbon compound chain has two parts. One end is known as head and the other is known as tail. The head contains COO negative and Na positive ions. Head is hydrophilic. What do you mean by hydrophilic? The end which react with water easily, that is called hydrophilic. It means the head react with water, whereas tail is hydrophobic. This is the structure of a soap molecule. Same detergent. A detergent is also a long chain of carbon compound and it has two ends. One is called head and other one is just tail. In detergent also, this is the structure of detergent and this one is soap. Tail, whether it is soap or detergent, it is hydrophobic. It means it doesn't react with water. It reacts with only with oil. Head, it is hydrophilic, whether it is soap or detergent. It means it reacts with the water. But the structure of head contains the different ions. In soap, it contains sodium ions, positive, or potassium ions. But in detergent, it contains sulfonic head. Sulfonic head means a long chain of sulfonic acid contained in detergent. This is the major difference between soap and detergent. Otherwise, both the molecules help in to cleaning the cloth. How the soap and detergent molecule help in cleaning the cloth? Cleaning action of soap. Cleaning action of soap to clothes, or we can say that how the soap molecules help into cleaning the clothes. As we have discussed, a soap has two ends. One is head and other is tail. Head is hydrophilic, that remains outside or upper side to the water. It forms this one like structures. but it is important to note down that there must be 15 to 20 molecules of this one like structures may be present in a micelle. What do you mean by micelle? Micelle is a cluster of soap molecules, just this one like structures. They may be 15 to 20 molecules. It contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 19. The 15 to 19 molecules, such like structures, which make a cluster in which head remains upwards or upper side of the water, because this is reactive with the water, whereas tail remains inside the water. Tail is hydrophobic, that doesn't react with the water. Tail part remains inside and head remains outside the water surface. This one like structure. This is tail and this one is head. Tail remains inside the water molecules, but it doesn't react with the water. It reacts with oily dirt. Oily dirt. As we know that mostly dirts in our clothes are in form of oil. Tail react with oil and head remains upper side of the water surface. Slowly the tail start to decrease the oil particle which are embedded into, which are stick to the our clothes and mix with the water. So it makes a cluster of large particle of carbon compounds that is called micelle. What is micelle? In soap or detergent, both the carbon long compounds form a cluster around the oily dirt. This cluster is called micelle. While preparing micelle, they start to cleaning the clothes. This is the cleaning action of cloth of soap as well as detergent. Now, the major difference between the soap and detergent is, first one is the head part. Head contains in soap whether sodium or potassium salt, whereas in detergent it contains sulfonic. This is the first difference. Second, a soap doesn't react with hard water, or we can say that soap does not produce foam or leather with hard water, but detergent produce foam or leather with hard water, because in hard water contains calcium or magnesium ions. The detergent decompose it, dissolve it and produce foam. It react with hard water. It doesn't react. This is the second major difference. Third one, the cleaning action of detergent is strong on cloth, but cleaning action of soap is not so strong. Not so strong as detergent. This is the major difference. And next one is, we can prepare soap at home, but detergent cannot be produced at home. They may be manufactured at industries. This is the major difference. One more question is, what is scum? Scum. As we know that underground water, all the underground water is known as hard water. Why it is called hard water? Because the underground water or hard water contain calcium or magnesium ions. These ions doesn't dissolve with soap, so they do not produce foam with the soap. This type of ions contain water is called hard water. When we use soap with hard water, we feel our skin sticky. whenever we use soap with hard water, our skin becomes sticky, and this is called scum. It means the hard water which doesn't produce foam with the soap, so that there is no cleaning action can be take place. This type condition is called scum. This is the cleaning action of soap and detergent as well as preparation of soap. We can prepare soap at home as we have already discussed. Take the vegetable oil and react with the sodium hydroxide or potassium hydroxide solution. Heat it 5 to 7 minutes. Add desired perfumes as well as color in the soap. We can prepare soap easily. Clear?